Right, an example of the independent t-test. This one is the same as the one that's in the book, but it's a good example, so I'm going to stick with it. So how much will a tutor charge? Well, let me read the question, because obviously trying to do it off the cuff is not working. So, will how much a tutor charges affect how well students do on the test? So you might think if you charge too little as a tutor, they might waste their time with you, right? They're not going to be paying attention, and they're like, oh, it's only like, a couple bucks an hour, whatever. I don't feel like thinking about statistics today. And you might then think, well, if I charge like 20 bucks an hour, that's a sizable amount of money for most people. And so they're going to be paying a lot of attention because they don't want to waste a minute. All right. So to test this, what you do is you have, let's see, 10 and 19. So you have 19 students who you're tutoring, and you randomly assign them so that 9 end up in the $5 an hour group and 10 end up in the $20 an hour group. I don't know if that was a coincidence, though, that the extra person just happened to fall into this more expensive category. Anyways, regardless, at the end of the semester, you learn what their final exam scores were. And these are the exam scores for the group that was in the $5 an hour condition. And these are the exam scores for the group that happened to be in the $20 an hour condition. And these are the two means. Now, we expect the means to be different, right? No matter what. In fact, they should be different because of sampling error, right? We don't have all the data. These are just samples, right? This came from a sample of people, and this was a sample of another group of people. So these means could simply be due to sampling error alone, but they could also be due to sampling error plus something else. So we need to find out what is most likely what's going on here. Is it sampling error, or do we have sampling error plus some sort of treatment effect? Now, why is this an independent t-test? Well, it's an independent t-test because the people who are in this group are an entirely different group of people from this group. So if you're a participant, that means you either fell into this category or you fell into this category. All right, you were not tested in both conditions. All right, it's also an independent t-test because we are comparing two means. We want to see if means are significantly different. We are not looking for the R word, all right, between this set of scores and that set of scores. We're not looking for the R word. We are looking for differences between their means. All right, and lastly, the participants have not been paired or matched, and you don't know what that means yet, but I will tell you, if pairing or matching is used, you need to be told that. That's not something you can guess. It needs to be written down somewhere. We plug the numbers into SPSS and run our independent t-test. And this first box, just remember, tells us some useful information, sample sizes for each group, their means, standard deviation, and standard error of the mean. Cohen's d I had to calculate with the online calculator. And we're not going to care about this Cohen's d so much unless we get a significant result. All right. Now, this would be a huge effect size if we get a significant result. So let's look at Levine's test first. Remember doing that in the lab? You have to look here first to know if we have homogeneity of variance. And to do that, well, here's our F value for Levine, and here's the sig value. So this is telling us the probability of this statistic. And we can breathe a sigh of relief because it's not significant. This number is greater than 0.05, So it's not significant. We are happy, right? Because we never want our S's to be significant. So we are happy. Happy people look up. That means we're going to look where it says equal variance is assumed, and we're going to look at this set of test results. If this had been significant, if this had been less than 0.05, then we would be sad, and sad people look down. So we would be looking at this row of data. All right, but that didn't happen, so we're going to look at this t-value, this sig value, and, this t-value, this degree of freedom, and this sig value. This is less than 0.05, so we have a significant t-test result. And that means that the effect, because it falls into that category where we would say this is a very, very large effect size. Cohen's D is telling us that. So we're very happy with these test results. We have found something. How do we write up the results in APA style or format? Well, you should recall the 5 elements of an APA write-up. And if you want to pause the tape now and try and write them up, try and identify them, that would be an excellent idea. I'm going to wait just a second here for you to pause, and then I'm going to tell you what the 5 are. Okay, so the 5 elements. Number 1, to test the hypothesis. So you're going to state what the hypothesis is about tutoring and test grades. The second is to identify the dependent variable. So we're looking at mean test scores, and I went into a little bit more detail here, but I said there were mean test scores for the $5 an hour group and the $20 an hour group. The third element is to identify the test that you're going to use to analyze the data. Make sure you have all relevant details, two-tailed independent t-test. The fourth one is to write up the results in APA format, the statistical notation, which is the italicized T and etc., all of that. And with independent t-tests, it's customary to include the mean and standard deviation for each group. And so I've got them here. This is the mean for the $20 an hour group and the mean for the $5 an hour group. And I put it or embedded this within the 5th element, which is to explain things in plain, simple English. So students who were charged $20 an hour did significantly better on their final exam than students who were charged $5 an hour. Now, there's a bit of jargon here. I include the word significantly, but even grandma could understand that students who were charged more did better than students who were charged less. All right?